So as per our project said, the fraud detection using AI, in this we create front end, back end, create database and create a AI using Python. In this, for making front end we use React.js. For making back end we use Express.js, and in database we use MongoDB. So in front end we create a two component, which is one is for normal user and one is for admin purpose. So when we go to the login page, we first try to doing sign in function and entering the password. So currently this user is in the database, so it can say the user is already exist, so it not allowed to add a new user. After that we go to login and we add the credential of the user which we try to add in previous transaction. So we try, when we log in, so this user is a role for admin panel. So so when he enters into the system show him the admin functionals. So it can show transaction, suspicious transaction, fraud, and blocked user, which is when user block the when an admin block the user for doing a fraud transaction, it can show here. After that, we add the credential of a normal user. So when we so in this normal user function, it can show up dashboard. When a transaction occur, it can show current balance, old balance, and from which category the transaction is occurred. In this field also it show total transaction which is doing. In this field we can add doing the transaction. So for doing the transaction we need the receiver's ID from which we want to send the money or something else. So from this database MongoDB we can do this. Here we create two database. One is for transaction, one is for user. In transaction we can show that we can do transaction many times. So when we in this field where we add receiver ID, recipient, amount, transaction type, device. After that when we do a transaction, it will go to the AI component of the system.
So now we switch to the backend part. Here we have used three models for making different predictions, and then we will use the most common prediction made by the three models. So first one is XGBoost classifier, and we have trained this model on a synthetic data set consisting of 5 lakh rows, and from this model we save it. The trained model has been saved as pkl files, and it is loaded here, and we have set various conditions as the probability is in a decimal in points, so we'll make it as according to these conditions. That is, if probability is less than 0.5, then we'll mark it as non-fraudulent, and in case it is between 0.6 and 0.8, it will be marked as suspicious, or if it is greater than 0.8, then it will be marked as a fraudulent activity. Next we will iterate through the columns and all, and we'll make it as a classification. Next we move on to the neural network part. Here also we have saved the neural network model, and we load that model using pickle, and this is the neural network that we designed. It is a basic neural network, and hence it had lower efficiency, so we move to the basic functioning of the model, and it also has the same as described above. So this is all the data frames and tensors and all, and we will classify it here, and that will be stored as NN prediction. And then we move on to the isolation forest, which comes under the category of anomaly detection. So that model again is trained, and we use the saved file. The models which are trained here were trained locally on our systems, and we saved their pkl files so that it would help us in making the the prediction part easier and faster. So again here we use these scores as these are based on the anomaly scores and not the scores that we defined. So this is based on the distribution that we got, and the next we will predict fraud from this. And again this is all the classification and all. Now this is collection and counter. We used this for ensembling these three models: the prediction from XGBoost, neural networks, and isolation forest. So what we'll do is we will take predictions from all these models, and the final decision will be given on the majority of the voting. So that is, if only one prediction exists, then obviously we'll give it, and if there are three different basically we can say all three are different, then we'll return the XGBoost prediction. And here we will link it with the MongoDB URL, and this is the connections. We get the user transactions and we'll fetch those transactions. So this is all the database part, and here we have generated the explanation for the classification that we made using Gemini API. This is the API call and all. So that API will Gemini will basically convert the prediction that we had into a human level language, so that the admin can easily understand why this classification was made. These are again the MongoDB calls, and this is the prompt that we used. And so after we finish all these user transactions and all, we can show that as a dictionary, and it will have three columns. So that is a classification, explanation, and the previous transactions. So we have used fast API for connection of the database and this IPYNB and all. So if the activity is classified as non-fraudulent, then we will give the explanation as safe, and in case it is not non-fraudulent, then we'll give the explanation that is given from the Gemini API. So as this is a non-fraudulent activity, we will see the explanation as safe. And in this case, the other example, just a second, this is a suspicious activity, as we can see here. So it will give the reason why the transaction is suspicious.